it says on the list that it's supposed to be Jukka Huupponen from Aro, but as you can see we are two, so we multiplied this morning. So I'm I'm from Juniper Networks, and I'm together here with Jukka Huupponen, and then we will do a joint presentation on the topic, which is building a secure network. And for the agenda,
and then we have a competition on the desk. There might be questions.
Listen carefully, and if you are more interested about the topic, there will be also a second presentation, which is this is the first one today, and also the last one today will be on the same topic. More kind of business focused presentation about SDSM, but only market.
Okay, so first I'll go through some general architecture and definitions of security, and then we'll come some building blocks now. What do you need to build security? Then we'll cover the first story, SDSM solution, how to build the architecture. So, we'll start with the definition. What is security? Hopefully, none of you are thinking it's some fancy colored box somewhere in your network. No, that's not security. Security, let's paint a scenario, or two scenarios. You're in a totally strange city, first time, middle of the street, middle of the night. It's total darkness, you can't see anything. And let's add some rain there, alright? Then, a scenario B, exactly the same spot, but it's a beautiful summer day. We're seeing sunshine. Now, which one of these scenarios do you feel more secure? Yeah, some might say first one, but I personally think the second one is the one you feel more secure. Why is that? What are the differences between those two scenarios? It's the exact same spot. First of all, it's light, and light produces visibility. When you can see something, you can react. So, for example, if there's a car coming, you can step aside and watch people hit by a car. That's visibility. Visibility game provides you help you survive or react to situation. So that said, I would say that security, visibility, plus control. And now if we move on and we think about the architectures. So if we think about the most secure places in this planet, so they're usually, or one might think they're military bases, or military areas or something like that. So let's take a military base as an example. How to build a security architecture. This is a simplified version, of course, and we're not going very deep into the security features they have there. Well, let's start with the outer perimeter. So they have fences around the base. They have a couple of gates. At the gates, they have guards with guns and stuff, so they're able to see and control anyone who's entering the base and going out there. So, and they might have some additional security as well, like metal detectors and some scanners that you could go through deeper security checks. Okay, then they might, inside the base, they might have another checkpoint or security point where they can check you again for a more secure place or a more secure area. And then it's a similar thing. They have a gate there and a guard, and they'll check your access if you're able to go there or not. What about the rest of the base? There is a need for visibility. So they plant some cameras there, surveillance cameras, video cameras. And they're carefully placed around the base so they can cover as much of the base as possible. So that information then is moved to like command center where you can see and monitor everything that's happening there. For example, someone is jumping a fence around the base from inside to outside or outside to inside. Doesn't matter. You can see it from the video screen, and then you can read it. So what does this have to do with anything with network? If we look at this picture, this is quite similar. And this is very simplified version of network architecture. Yeah, some Juniper switches and firewalls. Some other stuff. Well, so let's compare these two. So the military base of this picture. So at the perimeter, there's a gate. This picture is a firewall. Firewall, you all know firewall is there to control the traffic in and out. They are able to do more deeper scanning for the traffic as well, like IDP or some sandbox. Then there must be the other inside firewalls as well, or the inner gates. I left them out of the picture because it's almost the same that the firewall do. So, but the video camera part, that's interesting. It has to gain more visibility on the network and cover the part that the firewall can't cover. So what I've built here are taps and spans. And you can have taps and spans in the network to gain more visibility. And from there, shoot some traffic to the IDS systems or sniffers or whatever analyzers you're having to gain more visibility and knowledge of what's happening in your network. So to simplify that a bit, you have a lot of management systems. You can use the CM, for example, the Juniper JSA, where you can use the logs or some feeds from IDS or sniffers, so they can like alarm you what's happening. And it doesn't end there. At this moment I'll hand it off to Jani, who will tell about the Juniper solution, how it will simplify the management of this need what we just described.
So, how to build a military base version 2.0. We have introduced already a while ago something called SDSN. And today everything is about software defined whatsoever. And we came up with a quite easy acronym based on that called SDSN, calling software defined secure network. So the idea behind it is quite simple. So if you think about the military base example, we have someone sitting in the room monitoring the video screens and the surveillance data and whatever information we gather from the systems monitoring the perimeter. And what happens if they see a breach from the video camera? They will send the military police with the jeep and machine guns, and then they will arrest the guy or do whatever. We don't want to know about it. But what happens? It's quite manual operation. So somebody needs to do something based on the data, react. There is deploying time, so the military police is not immediately there. Same is actually happening on security point of view in many networks, because we might have even a dedicated team on a SOC watching the code dropping from the screen, like in the Matrix movie, and they might identify some sort of issue or infected host somewhere in the network, and then they need to react, do actions. So what do? They will investigate more, then they will maybe implement the configuration. But anyway, it's quite manual operation. In some cases, in bigger organizations, it might even require that you involve different teams for that. So the military police in this network dilemma can actually be networking team who can who can find where the host is, and then cut him out from the network. But it's manual operation. And today it's not fast enough. So our concept on the secure software-defined secure networks is to automate all of this, meaning that we have automated system which can detect what's happening, even it's unknown threat. It can automatically react on the threat, meaning that we do not need to deploy a different team, networking team, or military police to cut down the host for the threat from the network, but we can do it automatically. So we can push automatically and dynamically configuration to the network to prevent the damage to be spread further. So that's the pretty basic idea behind the whole SDSN concept. And we actually introduced the first version of it already about a year ago. The first version works like this. So we have different components doing different kind of things. And it actually introduces quite few new components. It's using existing technologies and existing methods to do things in the network. It's just reusing them a little bit different way. So we have something called secure fabric, which means in the phase one solution that you have world famous Juniper networking gear here on your premises, meaning NIA switches, UFX switches in the data center maybe. Then you have SRX series firewalls protecting the perimeter. Then you have management platform, which is our Space platform. We have a security director, which is the application to operate and see what's happening on the security devices, security devices. Then we have our cloud-based threat sandboxing technology called SkyATP. Then we have enforcement points. And this is actually when it gets interesting, because traditionally we have been able to dynamically push the policies to the firewalls. But to make the whole network to enforce your security policy, we are enforcing it also on the switching side. So think about that. You have someone who is bringing in the malware, which got to the host from using for example, Radisson Wireless over here, or network at home, or whatever, and walks straight into your organization and then plugs it on the network. That is pretty much, it's not downloaded through the corporate firewall, which we have seen in some case, but it's put directly on the heart of the operations inside the corporate network. So now with this architecture, we can actually see if there is malware which is trying to open a connection to the external command and control network through your perimeter firewall. And in the best case, it actually even already knows that if there is connections initiated to these addresses, it is identified that this is malware which might be doing it. And based on this data, we can actually push a policy or a firewall filter on the switch where the user is connected, and basically on the phase one, it's a simple layer 2 firewall filter. So it cuts down the network traffic from that specific user. And actually, nice thing also here is that it doesn't matter. But actually, what usually happens when somebody is coming to your corporate network, plugs the laptop, and it doesn't work, maybe because of this, there's a filter which is preventing the access from the infected host. The user tries another port, because there might be something wrong with the cable or the port. So in this scenario, actually, we can push the policy also to the new port. So it's not an easy fix for the user to just swap the port to get the network access. But if it really is the infection case, we can spread the policy all the way through the network, no matter where the user is putting the connectivity. Maybe some of you already thought that it's a nice thing, but there are challenges. It's not bulletproof because in the ideal world, how we see it, every one of you have only Juniper networking here. But that's unfortunately still today it's not the case. You might have Aruba wireless LAN, you might have Cisco switching, you might have HP switching gear on your network. So that's the reality. And for the phase 2, evolution version, so let's call it like a military base version 3.0. So in this case, actually, we integrate our SDSN solution to third-party networks, meaning that doesn't need to be any more Juniper switches on the network or things that we are creating, but we are also pushing the policy through external interfaces and APIs to also other vendors' networking here. So, for example, for the first one we tested was Aruba. So, for Aruba wireless LAN controller and Aruba ClearPass, we can actually say that if the host is residing on Aruba wireless, we can also cut the host down from the wireless side using Aruba wireless LAN controller and Aruba ClearPass. So that was the first one, and also, of course, it holds on HP other networking gear with the same method of blocking the user from the net. So that's easy and first implementation that we have introduced on the version 2.0. And on the previous example, we were committing basically configuration to our network gear in a form of firewall filter. On this one, we can also use radios, and meaning that if you're running .1x on the network, we can just push radios change of authorization and block the client from the network. There is still room for the phase 1 solution based on the firewall filter because we can also use the same kind of architecture on the data center. And as you might know, on data center, you might run .1x, but you want to have the same kind of automated threat prevention on the switching platform. And actually there, it's much more better if we have, for example, front port consisting of multiple VLANs towards your server infrastructure. You can push, again, firewall filter on the device, and imagine that you have a VM on the server platform. We don't want to block the whole VM from the network, or the whole host from the network, but only the single VM. So in this case, we can enforce the policy on the QFX platform just only for the one host which we see in the network. So it's a brilliant solution also for that side. And like mentioned, Aruba ClearPass is the first one to support this integration. If you're interested, we can show you a recorded video demo in our booth there, where you can also sign for the competition, and we can show more detail how it actually works. But it's quite neat. Also, new thing which we are bringing in on the phase 2 is the support for external feeds and external third-party feeds. Think about that you have a CM solution which can provide, as an easy example, it can be just an Excel list or list of IP addresses where you want to go or where you don't want to go. And you can actually use this list and push it to the policy enforcement. And this again pushes the list to the SRX firewalls, and then again it's populated also to the switching platform and to the wireless network in your organization. So it's also a nice thing to be able to integrate it to third-party feeds. In the future, it will also develop further, but you will see it then. But it's a quite nice architecture, and also the nice thing here is that we do not want to, our intention here is not to build like Juniper proprietary solution. We want to be open, just like I said, that it's the fact that there are many different networking vendors out there, and you might use different vendors. So we want to be flexible in our solution to be able to support all the things that you have out there in your organization networks. I think you might hear this a couple of times today. Not yet, I believe, because we are supposed to be the first one on the slot. But who doesn't know what is WannaCry? There's one guy, but he's working for F5, so we don't count. But anyway, you might see it and hear it many times during this day. I don't have a slide about it, but it's an interesting fact. Think about this solution and WannaCry and how it was spreading and how it created all the difficulties and issues it created. Can you guess how long it takes on this solution to block the host, infected host from the network? Less than an hour? Who thinks it's less than an hour? Less than half an hour? Less than a minute? Less than 30 seconds? Less than a second? You believe everything.
Should just go real quick, otherwise it's pointless.
Yeah, approximately 30 seconds. So 30 seconds, we can enforce the policy, it's off to them. So it's quite powerful in that sense that it's automated. Nobody needs to do anything. It's just, if you have it, the user gets infected, it's 30 seconds, it's cut off from the network, and usually that prevents quite a lot of further damage being done.
The 30 seconds was when it wasn't seen in the network before.
Yeah.
Why are you getting the feed of the descriptions?
Yeah. So the feed actually is on the first phase. It's coming from the cloud, like everything today. And what is actually in the cloud is our own malware detection platform, where we can do the sandboxing technology, where we run the VM. It's actually the inspection pipeline is three stages. So first we inspect based, if we see something that user is downloading something weird, we can inspect it or check it against if it's already known. So check it against the hash, if it's known or not. If it's not known, we will go further on the pipeline. We will inspect like the behavior of the malware. So if it's like executable file or if it's like internal parameters of the malware. And already on that point we can see quite a lot. And after that we move to the sandbox. And so in the max case, if we run it on the sandbox, then it takes like several minutes, 7-9 minutes, depending on the code. If we need to delay what are things or what are happening in the sandbox. But that will actually create the analysis, what is happening, why the file is doing what it's doing, and that gives the result or analysis for the file. Like that's the final step in the pipeline. And there we can, if it tries, for example, to initiate a connection to a list of IPs, we can easily extract that list of IPs and use it as a key, push it through to all the customers using it. Not only the one customer who has seen it, but all customers using the same solution. So it's, in that sense, it's a good solution. Also, it can be third-party external feeds. If you want to know which are the external feeds, you need to visit our booth. I can check it out. There are a couple of vendors who are providing the feeds. It actually in one form, as an example, it can be maximized geo-IP feed. So we can have a dynamic list which IP is mapped to which country. So if you want to have like a geo-IP option, you can use maximize external third-party geo-IP feed for this. People presenting these kind of things, they quite often apologize about busy slides. So this is an example of busy slide, but it's a good example because building this kind of solution, it's not only our products, but it's integration to multiple other products on the field. So for example, like I mentioned, the integration to ClearPass, we can have integration to Cisco ISC, we can have integration to Forescout, we can have integration to what's the end post protection?
Carbon black.
Black carbon.
Carbon.
So it's what?
Carbon
black, not black carbon. Carbon black. So it's a collection of different vendors and different partners that we are working with to build the complete solution for the software-defined secure networks. And I want to end the presentation for everyone looking at this. It's a nice example of multiple vendors working on the same challenges, and just to say that it requires more than us to build a complete solution. Thank you. We have 4 minutes for questions.
I do want to if your small medium bundle becomes let's say integration with different antivirus providers, so it's Sophos, it's Kaspersky, who else?
You can have Sophos, Kaspersky. You can have like a built-in or like all the signals in the box, or then you can have the cloud-based analysis. Depending, of course, one of them is more accurate, one of them is faster. Kaspersky is, Jukka might remember, it's inbox, or is it cloud-based analysis? So you have a choice of having everything, everything in the box, or then if you want to save space, disk space, and maybe if you run lower memory, right, you can use the cloud-based antivirus. On top of that, you can have the Sky ATP, which is the sandboxing technology, and that's available as a separate license for all the SRX users.
But the Sky ATP, can I run it also locally? Let's say inside my premise.
Not yet. It's running in Amazon Cloud, AWS. You can choose when you deploy your organization that if you want to run it inside European Union or outside European Union, and the reason you might be aware of. So when you deploy your organization in Sky ATP, you can choose that it's hosted inside European Union.
You mentioned 30 seconds. How do you achieve it with sandbox?
In that case, actually, it's already known. So, because we identified so many variations of the code that it's quite easily, when you get the first iteration, it already knows. So somebody has already detected what you're doing.
Sandboxing time.
Yeah, there's no time for the sandboxing.
So those 30 seconds apply to the already known threads, not to the new ones which not get the bigger filter or analyzed.
Yeah, then it might take the full pipeline of the analysis, so up to
It depends on how it goes, or how easily it is reverse engineer.
So in case that it's not literally like a new thread, it will take like several hours.
No, not
Hour,
hours.
minutes.
Yeah, so
Days or
maximum,
hours.
I remember, Yanni, was maximum was like 7-8 minutes.
7-8 minutes, that's the usual max. If we have
Then it's through the whole pipeline.
if we have malware which is like checking that it sits on the real environment where mouse is moving and you have normal network interfaces, not like any VM-based network interfaces, and it looks like a real. It's getting clever and clever all the time, and we try to be ahead of that. So it's this kind of chicken and egg kind of approach that people who are developing malware are getting more clever. We need to be able to find those technologies, what they're using. Actually, the mouse moving is quite clever because you are sitting in a VM. On the VM, mouse is not usually moving because there's nobody using mouse. So if the mouse is not moving, the malware can see that, okay, I'm sitting in VM, I'm not doing anything. So it tries to stay calm. So these kind of technologies we try to detect and mimic as close as normal user behavior as possible. So, and also they can see nowadays quite easily if they're triggered by time. So we need to be quite cautious of speeding up time. So if it takes like 10 hours for the malware to activate, we cannot wait for 10 hours. So there has to be a way how we speed up time without the malware detect that the speed has been increased somewhat.
If you detect it in the test, you send the information back is a patch or what? What is the decision that in the network cloud based on?
The decision is made, you mean for the, what we push
How do you
on
block it in the network there? You know it's bad in the cloud, it's for this file only, or is it the signature? You get all the files that are all merged. You know?
I would say it's a hash. We can check it.
So how do you get the signatures? How long does it take to get the signature? The single one.
All
So
the-
there is a team in the ISP that are doing the deeper analysis and pushing out the signatures.
Yeah, and then all the decisions what we do down here is based on the policy enforcer, which is like, it's like the component of VM sitting on the management platform, which is then talking to the side APP. So what we get here is, it can be, for example, a list of destination IPs that the host would like to access. So what is the form that we push down here? I don't really know the format of it, but as a result of it, we know what to block from the network, or where the hosts are, for example, trying to access. I don't know if it answers your question. So the answer is we don't know. We can find it out.
This is the good one.
Any more questions back there?
Yes, but what if the infected host starts spreading the malware in the local LAN? I mean, in the same subnet, where the host is. So how it is affected then?
Yeah, that's the point. So if it's sitting here, it's not trying to initiate any commands outside
Yes.
the network, so we don't see it. Then it's up to the host protection integration we do with carbon black. Then of course, then we don't know it, we don't see it in that case. You are in a right spot on that. And it has to be detected somewhere on the host or somewhere else.
But the host detection system also can report it to the policy enforcement, and that's how it stops it spreading. So it will be leaked out of the network.
On the EDX side, what additional licenses are required to have some security services on, say, inside as well on the switching side? Are there some additional licenses?
Good point. We are responsible for the technology, so the licensing is not our brightest side, but visit us, we can check it out. There's for example, ready-made licensing bundle for all of it.
So there was some licensing needed for the policy enforcer, but it was some device count license.
So how many devices you want to use to enforce the policy, and how do you count it? Because in the future, it might be even possible that you have routers, of course, like MXCs, J0 routers, whatever you want to push the policy, because that accepts similar kind of accesses that we are pushing. So the count of devices is where we want to push the policy. But we can check the license. And the whole thing is quite easily possible to test it quite easily as for example, virtual SRX can be found in the virtual form. You can do the same with virtual SRX. You don't necessarily need to have guys. You can have one switch which you can use, or then you have ClearPass where you can do the integration. One, then it's easy to do the testing against the existing devices. But if you want to test it against our switching platform, then of course that's also available for testing from Santa Monica or from us. So yeah, it's easy to build a test setup for testing. One more question.
One question from my side. If you run security directory to have policy enforcement, you need common space as well, right?
Yes.
And this type has come as a physical device and therefore you can run it on the virtual machine.
Yes, that's correct. So you can run the space platform in VM as well. And
But if you have already deployed an SRX platform, it's part of it. You still need physical hardware. So you can kind of embed it on the SRX.
you mean the space side?
Yeah.
Yeah, space can be either hardware or VM. The VM seems to be nowadays much more popular than the hardware. So you need space platform as a VM. Security Director is an application which is running on top of that. Policy Enforcer is a separate VM, which you install it as a VM, but then you say on the Security Director that this is my Policy Enforcer, and then it does the magic, and then you have it together. But it's a separate VM if you run on somewhere close to the Okay, our time is up. If you have more questions, visit our booth there on the main hall, and we will be here for a while before the next presentation is kicking in. But thank you for your time.